Hello students, we will start Maxwell's loop analysis. Maxwell's loop analysis or mesh analysis. Loop analysis or mesh analysis. So in network theory, we have already studied how you will apply Kirchhoff's voltage law. In Kirchhoff's voltage law, algebraic sum of the potential in a closed loop 0. In Maxwell's loop analysis or mesh analysis, if there is a mesh or in a closed loop, we have to apply Kirchhoff's voltage law, and there is a generalization of Kirchhoff's voltage law. So there is a formula. We will configure a formula which brings the formula is based on the resistance matrix into current matrix equal to voltage matrix. So Maxwell's loop analysis or mesh analysis, how we will apply KVL in a particular loop or mesh. In Maxwell's loop analysis or mesh analysis, now I am drawing a network. So this is your let R1, R2, and this is your R3, this is your R4, and this is your R5. So in this network there are three closed loop. This is your loop 1, this is your loop 1, and this is your loop 2, and this is your loop 3. In this is your three loop or mesh network. So this is your source V1, here there is your voltage source V2. So if you will apply Kirchhoff's voltage law, you can apply Kirchhoff's voltage law in first loop, and then second loop, then third loop. So this is your current, direction of the currents, I1 let, this is your I2, and this is your I3. I am assuming the current flow in clockwise direction. Suppose the current is your here I1, and here the current flow through, this is your I2. This is a common branch. Common branch means what? If the current I1 is flowing and here I2 is flow to the second loop, then what will be the current through this branch? I1 minus I2. So current flow through this branch is your I1 minus I2. Similarly, the current flow through this branch is I2, and here the current is flow I3, and the current flow through this branch is your I2 minus I3. First of all, I have identified what amount of current flow through the each resistance. This is your I1, this is your I2, this is your I1 minus I2, then this is your I3, this is your I3, this branch current flow through, this is your I3, and this is your I2 minus I3. Then apply KVL to the loop 1, then apply KVL to the loop 2, then apply KVL to the loop 3. So in Maxwell's loop analysis and mesh analysis, now we are going to calculate the unknown values, the current I1, I2, I3. So now let us apply KVL, apply Kirchhoff's voltage law, apply KVL to the loop 1, apply KVL to the loop 1. Already I told you the direction of voltage source from minus to plus is plus here. Here the direction of voltage source minus to plus is your plus here. Okay. Then in sign convention, if you move from plus to minus, that will be, we will consider minus. If we will move from minus to plus, then we will consider that will be plus. Here entering end is plus and leaving end is minus. Here the current entering here, this branch, this is plus and this will be minus. Current entering end, this will be plus and this will be minus. here entering this will be plus and this will be minus. Similarly, this will be plus and this will be minus. Are you getting or not? Then apply KVL to the loop 1. If you start from here, minus to plus plus V1, again plus to minus minus, then multiply current into resistance I1 into R1. Again, if you move from this one, plus to minus minus, current I1 minus I2 into R2. Are you getting or not? Algebraic sum of the potential in a closed loop 0. Summation of V equal to 0 or summation of IR equal to 0. If there is a voltage source, consider voltage source. If there is a resistance, then multiply the current flow through that resistance. What will be my equation? If I will apply KVL to the loop 1, here if you start from here, minus plus plus V1, then plus to minus minus, minus, this is your I1 R1, then here plus to minus minus, I1 minus I2, I1 minus I2 whole into R2 equal to 0. Are you getting or not? This is my first equation. If you will apply KVL to the loop 1, you will get this equation. So then if you will simplify this expression, now I am trying to get in a standardized form, so that V1 minus I1 R1 minus I1 R2 then plus I2 R2 equal to 0 or minus, bring the term containing I1, the term containing I1, this is your I1 R1, this is your I1 R2. If minus I1 taking common, that is your R1 plus R2 plus I2 R2 equal to plus V1, the right hand side this will be minus V2, or minus multiplied in each term, this will be plus I1 whole into R1 plus R2 minus I2 R2 equal to, this is your V1, this is your V1, this is your equation 1, okay, this is your equation number 1. Then apply KVL to the loop 2 or mesh 2. Apply KVL to the loop 2. Apply KVL, Kirchhoff's voltage law, to the loop 2 or mesh 2. Same thing. If you move from plus to minus, considering minus sign, if you move from minus to plus, this will be plus. So algebraic sum of the potential in a closed loop or mesh 0. Summation of IR equal to 0 or summation of V equal to 0. If there is a resistance, multiply with current. So in loop 2 there is no voltage source, only there are 3 resistance. You should multiply the current flow, multiply current with that resistance. If you move from here, plus to minus minus, minus I2 into R3, then plus to minus minus, the current flow through this branch is your I2 minus I3, whole into R4. Then again this is your minus to plus plus, that is a clockwise, minus to plus plus, plus current flow through this branch is how much? I1 minus I2, whole into R2 equal to 0. So this is my second equation, and then simplified this expression, that this is your minus I2 R3, then minus I2 R4, again minus plus I3 R4, then plus I1 R2 minus I2 R2. There are 3 resistance. First is your I2 R3 minus I2 R3, then minus I2 minus I3 whole into R4, again minus plus plus, I1 minus I2 into R2 equal to 0. So I2 R3 minus I2 into R4 plus I3 into R4 plus I1 R2 minus I2 R2. Then if we will rearranging these terms, first term should be the term containing I1, then the term containing I2, then term containing I3. So this is your I1 term here only, I1 R2. So I1 R2, then this is your term containing I2, the term containing I2, the term containing I2. There are 3 terms containing I2, and if we taking common minus I2, this is your R2 plus R3 plus R4, R2 plus R3 plus R4, I2 R3, I2 R2, then I2 R4, then next I3 plus I3 R4 equal to 0. Then slightly modified this expression so that if we multiply minus sign in each term, this term will be how much? Minus I1 R2, and this will be plus I2 whole into R2 plus R3 plus R4, here minus I3 R4 equal to 0. This is my second equation. If you apply KVL to the loop 2 or mesh 2, you will get this expression. This is your equation 2. Then next apply KVL to the third loop or third mesh. Apply KVL, Kirchhoff's voltage law. Apply KVL to the loop 3 or mesh 3. Already I told you, if you move from plus to minus, considering minus, and if you move from minus to plus, that will be plus. In a loop 3, there are 2 resistance and there is a voltage source. So if there is a voltage source, considering this voltage source, if there is a resistance, multiply with current. This is your resistance R5, the current flow is your I3. If you move from a clockwise direction, plus to minus minus, minus I3 into R5, minus I3 R5, then here plus terminal minus terminal, plus to minus minus, so minus V2, again this will be minus to plus plus, plus that is your I2 minus I3, this is your I2 minus I3. In this branch the current flow through this branch is I2 minus I3 into R4 equal to 0, or minus I3 R5 minus V2 plus I2 R4 minus I3 R4 equal to 0. Are you getting or not? Then if you rearrange this term, the term containing first I1, then the term containing I2, the term containing I3, like your previous expression, the term containing I1, the term containing I2 here, the term containing here, that is your I1, term containing I2, the term containing I3. In this equation there is no I1 terms. Next come to the term containing I2. This is your term containing I2. First write down this term I2 R4, then the term containing I3. There are 2 terms containing I3. Then minus I3 taking common. So minus I3 taking common, that is your R4 plus R5. Then minus V2 equal to 0. If we multiply minus term, that will be how much? The first term, this is minus I2 R4 plus I3 whole into R4 plus R5 plus then plus V2 equal to right hand side, that is your minus V2. This is your expression 3, equation 3. This is your equation 3. Okay, if we will solve this 3 equation, I will get the 3 variables I1, I2, I3, then you can get I1, I2, I3. what I am trying to get the form, that is your resistance matrix into current matrix equal to voltage matrix in Maxwell's loop analysis or mesh analysis. In Maxwell's loop analysis or mesh analysis, that is your the resistance matrix into current matrix R into I equal to V, R into I equal to V. If this here in this network there is 3 loop, means there will be 3 into 3 matrix will form. So resistance matrix should be 3 into 3. Like this is your resistance matrix will be R11, R12, R13, R21, R22, R23, R23, R31, R32, R33. This is your 3 into 3 matrix, resistance matrix into current matrix. Current, there are 3 currents, I1, I2 and I3. So I1, I2 and I3. I1, I2, I3 equal to the net voltage. There are 3 loops, that is your net voltage in the loop 1, that is your V1, net voltage in the loop 2, that is V2, and the net voltage in the loop 3, this is your V3. Are you getting or not? That means, so this is your R11, R11, R12, R13 in previous slide, R21, R22, R23, R31, R32, R33. So this is your resistance matrix into current, that is your I1, I2, I3. Then voltage, the net voltage in the loop 1, V1, V2 and V3. So this is your net voltage in the loop 1, V1, V2 and V3. So already in 3 into 3 matrix, so we have to find out or calculate the value of I1, I2, I3 using Cramer's rule. In Cramer's rule, how will you find I1, I2 and I3? So in Cramer's rule, how will you find I1? First of all, this is your determinant of R. First you have to calculate the R. R means the determinant of the resistance matrix. So how will you get the resistance determinant? This how you get the determinant of R? The R11 into, if you multiply this into this minus this into this, R equal to how much? That is your R11 whole into R22 into R33 minus R23 into R32, isn't it? So this, if you close R11, this into, if you close this row, column and this row, you will get this 4. So this into this minus this into this, R11. Then middle term will be minus, because in a same order. Then second term, that is your R12, R12 whole into, if you close this one, R12 means this one, you will get this into this minus this into this, R21 into R33 minus R23 into R31, then plus R13 is how much? R13 means, if you close this column and this row, this is your plus R13 means this R13 lying in this row and this column. So that's why if you close this one, you will get only these 4 terms, 4. So that means if you multiply this one, R21 into R32, R21 into R32 minus R22 into R31. In this way already you have studied in 12th. So you can find out the value of the resistance matrix. Then the question is how to find I1 in using Cramer's rule. In Cramer's rule, now I am discussing that is your Cramer's rule to how to find out the value of I1, I2, I3. If there are 3 simultaneous equations, in previously there are 3 simultaneous equations involving I1, I2, I3. Using Cramer's rule, you have to find out the value of I1, I2 and I3. So I1 is how much? I1 is nothing but R I1, this matrix divided by this R. So how to calculate R I1? R I1 is nothing but what? this matrix is how much? Ri1 means if you close this column, you have to consider this 4, this resistance matrix along with this voltage matrix. If to find out the value of I1, first if you close this first column, then you have to consider this one, V1, V2, V3. That means there are 4 columns, 1, 2, 3 and 4. If you are going to calculate the I1, simply first column you close, then considering this column V1, V2, V3, next remaining 2 columns, that is these 2 columns. So that is your R12, R22, R32, then R13, R23, then R33. This is your Ri1. So Ri1 equal to this one. If you divided this, find out the value of Ri1 using this formula, V1 whole into this minus this into this, minus R12 into, that means this into this minus this into this, plus R13 into this minus this into this. In this way you can find out the value of Ri1. Similarly Ri2. How to calculate Ri2? Ri2 is nothing but what? Sorry, Ri2 is how much? Ri2 means we have 4 columns, 1, 2, 3 and 4. 2 means what? Simply close the second column. Left side you will get 1 column and then considering this column and this column, Ri2. So in Cramer's rule, when you are going to calculate the current I2, means second column you close. In left side you will get only 1 column. First consider this column. That is your R11, R21, R31, then what? V1, V2, V3, V1, V2, V3, then remaining that one is your R13, R13, R23, R33, R33, this column. So if you once you get Ri2, same procedure like this one, this into this whole into this minus this into this, minus V1 into this minus this into this, plus R13 into this minus this into this. You can find out the value of Ri2. So I2 is how much? I2 equal to Ri2 divided by, that is your this determinant R. This is nothing but I2. Ri2. Same thing Ri3. Ri3 means third column. If you close this third column, left side, how many columns you will find? 2 columns and remaining was this one. So Ri3, if you close this column, you will get these 2 columns. So that is your R11, R21, R31, then R12, R22, R32, then V1, V2 and V3. This is your Ri3 and I3 equal to, that is your Ri3 divided by your this determinant R. So in this way you can find out the value of I1, I2, I3 using Cramer's rule. Are you getting or not? One thing is, this is your, in this determinant R11, what do you mean by R11? Sum of the resistance formed by the loop 1. R11 is nothing but sum of the resistance formed by the loop 1. In Maxwell's loop analysis or mesh analysis, here there are 3 loops. R11, how to calculate the value of R11? So R11 is nothing but sum of the resistance formed by the loop 1. That in the loop 1, how many number of resistance? 2 resistance, R1 and R2. That is your R1, R2. Sum of the resistance formed by the loop 1, that is your R1 plus R2. And R12, R22 is how much? R12 is how much? Resistance common between 1 and 2. This is your loop 1 and this is your loop 2. Which resistance is common? That is your R2. If the common resistance, put the minus sign. This will be minus sign. Similarly, R13, 1 and 3. Is there any resistance common between 1 and 3? No. So that's why the value will be 0. In these three equations, so in these three equations, equation 1, equation 2 and equation 3. If you are rearranging this equation, that is your what? The rearranging this equation, the value is how much? R1 plus R2. If you rearrange this equation, that is your R1 plus R2. See, R11 is nothing but, if this one, this value I can write here R11. R11 means sum of the resistance formed by the loop 1. R11 I can write here, that is your R1 plus R2. Is not it? The sum of the resistance formed by the loop 1, R11. 1, 2, common between 1 and 2. The resistance common between 1 and 2 is how much? Only R2. And put the minus sign, minus R2. Then 1, 3. Is there any resistance common between 1 and 3? No. So that will be 0. That will be 0. That will be 0. Similarly, R21 common between 1 and 2 is same as 2, 1, 1, 2 same. 1, 2 common R2. That will be minus R2. R22 sum of the resistance formed by the loop 2. Look at this. This is your diagonal. This diagonal means what? R11 means sum of the resistance formed by the loop 1. Sum of the resistance formed by the loop 1. In loop 1, how many number of resistance? R1 plus R2. R11. R22 means self loop 2 or self mesh 2. This self mesh or self loop, how many number of resistance? 3 resistance. R2, R3, R4. If I will tell you what is R22, sum of the resistance formed by the loop 2. That is your R2 plus R3 plus R4. Similarly, if I will say R33, sum of the resistance formed by the loop 3. In loop 3, that is how many number of resistance? Only 2 resistance, R4 plus R5. If there is 1, 2, 2, 1, 3, 1, 3, 2 like this, these are the common between 1, 2, 2, 3 like this. 2, 1 is same as 1, 2. So this is your R21. R21 means the resistance common between loop 2 and loop 1. That is only R2, put the minus sign. R22, already I told you, sum of the resistance formed by the loop 2. R2 plus R3 plus R4. R2 plus R3 plus R4. And then R23, 23. There is a resistance R4. Put the minus sign. That will be minus R4. Is not it? Then come to R31, 1, 3, 3, 1, same. 1, 3. There is no resistance common between first loop and third loop. It will be 0. Then 3, 2. 3, 2 means 2, 3, 3, 2 same. 2, 3. There is a common resistance R4. Put the minus sign. Minus R4. Then 3, 3. Already I told you. 3, 3 means self loop 3. Sum of the resistance formed by the loop 3. That is your R4 plus R5. That is your R4 plus R5. This is your resistance matrix. Then if this multiply with current, that is your I1, I2 and I3. Isn't it? I1, I2, I3 is equal to V1, V2, V3, which equal to V1, V2, V3. That means V1 is how much? It is important. If the V1 means net voltage in the loop 1. In the net voltage in the loop 1 means the net voltage, if there is only one voltage source. If the direction of the current is same as the voltage, it will be plus. Look at this. This is a clockwise direction. The I1 current is same as the voltage direction. The current direction is same as your voltage direction. That will be plus. So this will be V1. And if V1 in voltage matrix, that will be V1. Similarly, loop 2, there is no voltage. So V2 equal to 0. V2 equal to 0. In the third, look at this here. the current direction is like this is your clockwise and the voltage direction is like this. This current and voltage is opposite. The net voltage is your minus V2. So V1 value that is your so this is nothing but I can write this is your R1 plus R2 minus R2 0 and minus R2 and second R2 plus R3 plus R4 and this is your minus R4, then 0 minus R4, then R4 plus R5. This is your resistance matrix and this is your current matrix, that is your I1, I2 and I3, and the net voltage in the loop 1, the direction of current is same as voltage, this will be V1, and V2 there is no net voltage, so that will be 0. In third loop the direction of current and voltage is different, net voltage is your minus V2, this will be minus V2 and this will be your equation. So without calculating all these things, if I will see this network, I can direct write in this expression. First, if you must be write resistance into current equal to voltage. If there are 3 loops, there will be 3 into 3 resistance matrix and unknown variable I1, I2, I3 and the net voltage V1, V2, V3. So first this is R11, R12, R13, R21, R22, R23, R31, R32, R33. Net voltage in the loop 1, net voltage in the loop 2, net voltage in the loop 3. But the question is, if you have to carefully, if you considering the sign convention, when you are going to the voltage matrix, the direction of the current source must be same as the voltage source. Here the direction of the current source is clockwise and the voltage direction is upward, is same direction. So that's why this is your V1 positive. Second loop there is no voltage source, the net voltage is 0. In third loop the direction of current source is opposite the direction of the voltage source, so this will be minus. Are you clear or not? Then if I multiply this, whether my equation is satisfied or not, look at this first equation. If you multiply this one, matrix multiplication, R1 plus R2 into I1 plus I2 into minus R2 plus I3 into 0 equal to V1. Look at this equation satisfied or not? This is your I1 into R1 plus R2, R1 plus R2 into I1, R1 plus R2 into I1 minus I2 R2 minus I2 R2 0 into I3, there is no term containing I3 equal to V1. Is not it? This equation is satisfied or not? Come to second, minus R2 into I1 minus I1 R2 minus I1 R2, then plus I2 into R2 plus R3 plus R4, R2 plus R3 plus R4 minus I3 into R4 minus I3 into R4. In there is second net voltage 0 equal to 0. Are you getting or not? My equation is satisfied with this condition or not? Then come to third equation. If you multiply this one, I1 into 0, there is no term containing I1, that's why I1 into 0, there is no term containing I1. Then minus R4 into I2 minus R4 into I2 plus I3 into R4 plus R5 equal to minus V2. Are you getting or not? My 3 equation is satisfied or not? This is a standard formula. Without calculating all the things, using Maxwell's loop analysis or mesh analysis, I can write this matrix form. First of all, care should be taken that is resistance matrix into current matrix is equal to voltage matrix. So if there are 3 loops or 3 mesh, the resistance matrix will be 3 into 3. R11, R12, R13. 1 means self loop 1. Sum of the resistance formed by the loop 1. And R22, sum of the resistance formed by the loop 2. R33, sum of the resistance formed by the loop 3 in diagonally. This is a self loop. This is the sum of the resistance of the loop 1, sum of the resistance in the loop 2 and the sum of the resistance in the loop 3. And here 1, 2 is same as 2, 1, 2, loop 1 and loop 2. Loop 1 and loop 2, if there is any resistance common between 1 and 2 or 1 and put the minus sign only. So 1, 2 and 2, 1, the resistance is R2, put the minus sign. Similarly 2, 1, 2, 2, 2, 3. 2, 3 means loop 2 and loop 3. If there is a resistance common between 2 and 3, put the minus sign. Similarly 3 1, 1 3 3 1 is same 0. So there is no resistance common between 1 and 3, that's why it is 0. Then 3 2, 3 2 2 3 same 2 3 R4, put the minus sign, then 3 3, the net resistance in the loop 3, that is your R4 plus R5. This is your unknown current I1, I2 and I3. This is your net voltage V1, V2 and V3. V1, care should be taken if you are going to calculate or writing the voltage matrix. So V1 means net voltage in the loop 1. If the direction of the current source is same as the voltage source, it will be same sign, that is your V1. If there is another voltage source is there, then you have to calculate the net voltage and the direction of the current. If the same as voltage, it will be plus, that will be V1. And there is no voltage source in loop 2, that's why 0. And in third loop, there is a voltage source, the direction of the current source is opposite to the voltage, put the minus sign. So in this way, you can write this matrix form, then find out I1, I2, I3 using Cramer's rule. And here also already I told you in Cramer's rule how we will calculate the I1, I2, I3. This is your I1, I2, I3 resistance matrix, current matrix and voltage matrix. So simply calculate the mod R, means this value of the resistance matrix. So you can find out the value of R mod R, then R I1 to calculate the unknown quantity I1. I1 means first column, you close this first column, respective this 1 means 1, that means you close this one, you will get these 4 terms, this into this minus this into this. This is your RI1. RI1 means first close this first column and considering this V1, V2, V3 and these 2 column. This is your RI1 matrix, and if you divided this value of this divided by resistance R, you will get the value of I1. Similarly RI2. I2 means if you close this column 2, then left side that is 1 column and you consider this column, then another one is your V1, V2, V3, then this R1 third column. The value of this divided by the resistance matrix, you will get I2. Similarly 3 means you have to close this third column. If you close this third column, left side there are 2 column, this one and R11 to R31, R12 to 32, then V1, V2, V3. In this way you can find out RI3, and if you divided this resistance matrix, you will get the value of I3. In this way we can calculate the I1, I2, I3. Then once you get the value of I1, I2, I3, then you can easily calculate the what amount of current flow through the each branch. Here the branch through R1 is I1. Whatever the I1, you consider I1. What is the current flow through the R2 is the question asked. What amount of current flow through the R2? Once you get I1 and I2, simply the current flow through the R2 is I1 minus I2. Then what amount of current flow through the R4? That is your I2 minus I3. So each branch you have mentioned what amount of current through the each branch. Once you get I1, I2, I3, then each branch what amount of current flow through you can easily calculate. So this is nothing but Maxwell's loop analysis or mesh analysis. Before, when the problem, as far as problem solving is concerned, if you are going to calculate using mesh analysis or loop analysis, some brief point, some of the tricks you must be know. The tricks is if there is a current source is there, if there is a current source, you have to convert it to the voltage source. In Maxwell's loop analysis or mesh analysis, if there is a current source in a problem, there is a current source is given, you have to convert it to the voltage source. As already you know, the in source conversion, so if there is a current source, is given, suppose this is your I and there is your R, the current source, and if there is a current source, the resistance must be parallel. If there is a current source resistance to the parallel and you are going to calculate using Maxwell's loop analysis or mesh analysis, you have to convert current source into voltage source. So voltage source equivalent versus voltage source is how much? I into R. Look at this is your current direction is upward. That's why your upward means the voltage direction from minus to plus is plus, already I told you. So this is your plus terminal and this is your minus terminal. So this is your voltage I into R, V equal to this value I1, I into R, and resistance will be series. This is your R. So this is your equivalent conversion, source conversion, current source to voltage source. When we are going to calculate using the Maxwell's loop analysis or mesh analysis, first of all in a problem you have to convert, if there is a current source, then convert it into the voltage source. So like this one, current source parallel with resistance, then I into R you will find the voltage, the direction of minus to plus is plus upward, that means this will be satisfied, and the resistance will be series. Suppose there is a number of voltage sources are there, number of voltage sources are there, V1, V, and this is your V dot dot, or equivalent is nothing but the same voltage. If the voltage sources are parallel, the same voltage, instead of considering number of voltage source, you consider single voltage source, that is your same voltage source V. But in case of current source, suppose same thing, if the current source I, another current source I, this is your I, so equivalent is how much? Same though, same, the current flow through the, in a series the current flow through is same, so equivalent is nothing but same I. If there is a voltage source, suppose this is your V1, again that is your V2, V1 and this is your V2, equivalent is nothing but what? Minus plus plus, minus plus plus, equivalent is nothing but V1 plus V2, this is your V1 plus V2. So another thing is, suppose there is a resistance here, again there is a resistance, suppose there is a current flowing through this one, so this is R and this is I. When we are going to solve the different type of numerical problems, you will find the current source may be parallel with some resistance, or the voltage source some series with some resistance. The basic tricks you must be know. If the current source is like this, so the equivalent figure will be like this. It is for easy for you. This one. This is I and this is R. This is R. So this is the source conversion. If any problems or numericals, the current source is given, first of all you have to convert it into voltage source, then consider how many number of loops or mesh. If there are two loop network or 3 loop network, the resistance matrix will be, if 2 into 2 loop networks, the resistance matrix will be 2 into 2. If this is a 3 loop networks, the resistance matrix must be 3 into 3. And if there is 3 loop, the 3 currents I1, I2, I3, same procedure you can calculate I1, I2, I3 using Cramer's rule. Today I will now stop this. Next class we will start numericals and different type of numericals we will do. Thank you.